Hi, my name is Danny Fritsch. I'm a third-year PhD candidate, and I'd like to welcome you now to the Stability Wind Tunnel. So this is the largest wind tunnel we have here at Virginia Tech, and it's one of the largest university-owned wind tunnels in the United States. We're going to take you into the test section in a little bit, but you'll see this is a very large wind tunnel. It's big enough that you can stand up inside the test section. And we do both academic research as well as a lot of industry research here. So right now we're standing in the control room. This is where the engineers sit while they're doing their wind tunnel experiments. Right here next to me, this is the control box, and this is where you can control the speed of the wind tunnel by driving the fan. And over here you can see behind me and to the side there's an array of screens. And what we can do while we're in here is we can monitor everything going on in the wind tunnel, the speed of the flow, the temperature and density, as well as some stats on what's going on with the motor and the drive, just in case there's problems, as well as all of our data acquisition systems and monitoring of what's going on in the test section. So next up, I'm going to take you into the tunnel itself. And in order to do that, we have to walk through this airlock here. And as you can see, these have some really big doors on them. And the reason we need the airlock, this tunnel will run up to about 200 miles an hour. And when it does that, the ambient pressure in the actual tunnel section will drop. So we have this airlock here to separate the engineers from the wind tunnel when that pressure drops. It's not dangerous, but it's pretty uncomfortable. So now we're in the main tunnel area. You can see the test section is that silver part that's above and behind me. So you can see this is a really big facility, and it actually extends out of the building right over here in front of me and then back behind us. This is a really big facility, and it actually did not start here at Virginia Tech. It was donated to us by NASA in the 1950s, then shipped it here down the highway and put it back together piece by piece. And since then, we've done a lot of modernization to the tunnel to get it ready for research in the 21st century. One of the biggest things we've done is this is the first ever hybrid anechoic wind tunnel. So what that means is you see behind me, this is the wall of the test section, and right now it's in what we might call its traditional or its aerodynamic configuration. But we can actually pull that wall out and replace it with one made entirely of Kevlar. And what's cool about the Kevlar is that it presents a solid barrier to the flow. So aerodynamically it acts like a normal wind tunnel, but it presents almost no barrier to sound. And then what we can do is we can back up these really large chambers right here. We call these the anechoic chambers. And you can see it's basically a really big box filled with acoustic foam. And we back that up right up against the tunnel, and we can put all kinds of acoustics instrumentation in there to measure the sound of flows going on in the wind tunnel. And that makes this facility really popular with a lot of industry partners like GE, who come here to do aeroacoustic testing for things like wind turbine blades and aircraft landing gear. So now we're going to go ahead and take you up into the test section and talk about some of the capabilities of the tunnel. Alright, so now we're standing in the test section. To give you a sense of scale, I'm about 5'11", so this is around 6 feet, maybe just a little bit more higher. And it's a square test section on either side. So what's really cool about having a test section this big is we can bring in full-scale or close to full-scale models, particularly for our industry partners. And we have put all kinds of stuff in this test section. Airplane wings, landing gear, submarine models, and even a couple of times we've had people come in and stand in here to test out hurricane winds for the Weather Channel. My research focuses on the boundary layers that go on the wall. And as you can see, we've got these walls are made out of individual panels. And that's a really cool design feature we've put into this tunnel so that you can swap things out. And the instrumentation capabilities we have here are really remarkable. So now we've taken you back to the drive fan for the wind tunnel. The blades themselves are down right now for repair, but this gives you a real sense of the scale of the facility. The fan behind me is about 15 feet in diameter. One of the really cool things about this facility is that it offers both graduate students as well as some of our undergraduate students the opportunity to come in and do real hands-on research in a world-class aerodynamic facility. Right now we have 4 projects going on inside the wind tunnel that represent 7 graduate students and 2 postdocs who are in here regularly. In addition to that, every year we have around 400 undergraduate students come through the tunnel as part of their undergraduate lab experience, and we're always taking on new projects both inside and out of the aerospace engineering department. With that, I want to thank you again for coming to see this Utility Wind Tunnel review. If you have any more questions about this facility, please see the website.